Good evening. My name is SAURABH KUMAR. So we are continuing our subject engineering mechanics topic lifting machine. So in last lecture I give you the example. So I hope you have already done that example. In that I have already show you first part how will you do. So we will do second part. I think some of you have done already in second part. If somebody have problem, now we will solve how we do it. So in second part what we have to find, second part we have to find is the in lifting machine whose velocity ratio is given, effort is given, and to the lift load of 4 km. Is the machine reversible? We already find yes, we got the answer. And second, if so, what effort should be applied so that the machine is a point of reversing? So we have to find what effort is required at the point of reversing. So we already find out the machine is reversible or not. We got 80%, so it is reversible. Now which second part? So we know at the point of reversing means, what is the point of reversing is when efficiency is 50%, because below 50% it is not reversing. So we have to above 50%. So point of reversing is efficiency will be 50%. Here we let P1, and P1 is effort required to lift a load of 4000 Newton when the machine is at the point of reversing. Okay, if we let, so now what will be the mechanical advantage? W upon P1, and W you already know 4000, P1 is P1, we have to find out P1. So a mechanical advantage is equal to 4000 upon P1. So we put MA value, we already know MA is point, MA is 4000 upon P1. Now efficiency, what is the efficiency? Efficiency equal to mechanical advantage upon my velocity ratio. Okay, so here's efficiency is 0.5. So mechanical advantage upon velocity, so we already know efficiency is 0.5, whose MA is 4000 upon P1, and VR is 50. So what is efficiency? 0.5 is equal to 4000 upon P1 upon 50. We got 80 upon P1. So what we get P1? P1 will be 160 Newton. So I hope that some of you have already done it. It's not that hard, and if you don't understand, you can see this. Now we will go next point, law of machine. What is law of machine? The term law of machine may be defined as relationship between the effort and the load. So law of machine gives the relationship between effort and load. So when, thus for any machine, if we record the various effort required to rise the load, means we are given for given loads how much effort is required, when we find out the relationship by the graph, we find out that it is the plane relationship, straight line relationship. You can see here it is straight line relationship between load and effort. Okay, now we have to find out mathematically. Before that, mathematically, this you are seeing that this, it is starting from some point, some height will be there. Okay, this is called, why is happened? The intercept OA represents the amount of friction offered by the machine or in other words, this is the effort required by the machine to overcome the friction. Means when you starting the machine, in the start you have to overcome some friction, then only you can lift some load. So minimum load if you are nothing is load is there, again you have to find, you have to effort is required, or that effort required to overcome the friction. So this height is to overcome the friction. Okay, so the height of OA is overcome the friction. So now we will do is by mathematically how we will define the law of machine. So it is straight line equation. So straight line equation is P is equal to mw plus c. Here P is effort applied to the lift the load. M is a constant here which is coefficient of friction, or it represent the, in the mathematical term it represents the slope of the line. Here W is load lifted and C is another constant which represent the machine friction. Okay, so here P and W you already know, effort and load. M is slope, the slope of this line. Okay, and C is the friction, the constant friction required, this friction required, this represented by C. Okay, so now we will do one example. What load can be lifted by a effort of 120 Newton if a velocity ratio is 18 and efficiency of machine is of load is 60%? Determine the law of machine if it is observed that the effort of 200 Newton is required to lift a load of 2600 Newton, and find the effort required to run the machine at the load of 3.5 kilonewton. So in this question two or three things are required. First he asked determine the law of machine, means he want to that equation, means he want M and C value. Second he asked find the effort required to run the machine at the load of 3.5 kilonewton. Okay, so first we have to find out the law of machine, the equation, and then we find out to require the effort required to load of 3.5 kilonewton. Okay, so what's given here? Given is effort, velocity ratio given, efficiency is given. Okay, so now we have to find the equation. For that equation let we consider W is load lifted by the machine. Okay, so what is MA? MA is mechanical advantage, which will be W upon P. Here P is given 120 Newton and W we have taken. Now we know efficiency. The efficiency is equal to mechanical advantage upon velocity ratio. Okay, so efficiency is given is 0.6. So we put the value of MA here. So what will be W upon 120, and P is, or velocity ratio is given is 18. So what will be 0.6 is equal to W upon 120 upon 18, means 0.6 is equal to W upon 2160. We can find here W value, which will be 1269. Okay, so now what is law of equation? P is equal to mw plus C here. Okay, P is given 200 Newton, W is given 2600 Newton. Okay, so now we can put in equation. One equation will be 120 is equal to M into 1296 plus C, and other equation will be 200 is equal to M into 2600 plus C. Okay, so for that we have two equation and two unknown. So we can easily find out. So value of m will be 0.06, means slope of the line is 0.06. And value of c, when we putting m value here in any of the equation, when we put m value we can find c. So c will be 44. Okay. So now we have the equation, we have m and c. So we have the equation p is equal to 0.06 into w plus 44. We have to find the first, and second, what's they asked, effort required to run the machine, the load of 3.5 kilonewton. So in this equation, when we put the value of w, we can find the effort. So when we putting the value of 3.5 kilonewton means 3500, we are putting in newton, we will get the answer of effort 254 newton. I hope you understand. Okay, now we know the law of machine. Now what will the maximum mechanical advantage of the lifting machine? We have to find the maximum mechanical advantage. What will be? We already know mechanical advantage is equal to W upon P. So for maximum mechanical advantage, we put the value of P is equal to MW plus C. When we putting the value of here, P value W upon P, P value is MW plus C. So we get in terms of W. Okay. So what we get? W upon MW plus C. Here when we again rearranging it, we will get 1 upon M plus W upon C. Okay. If we neglecting this C upon W, what we will get? MA, mechanical advantage, maximum mechanical advantage will be 1 upon M. So here with our answer is maximum mechanical advantage is equal to 1 upon M. Okay. Similarly, we have to find maximum efficiency of lifting machine. So efficiency will be mechanical advantage upon velocity ratio. So mechanical advantage will be W upon P, and velocity ratio will be VR. So when we rearranging W upon P into VR, we already know mechanical advantage maximum when is 1 upon M. Okay. So for the maximum efficiency, substituting the value of P, MW plus C. Similarly, when what we have done is mechanical advantage. Similarly, we do for efficiency. So equation will be maximum efficiency is equal to W upon MW plus C into VR. Here we again rearranging it. We got 1 upon M plus C upon W into VR, and we neglecting when C upon W, we got 1 upon M into VR. Okay. The same maximum efficiency we also find out by using the maximum mechanical advantage. Okay. This is second method of finding the maximum efficiency. We know maximum efficiency will be maximum mechanical advantage upon VR, and we already know maximum mechanical advantage will be 1 upon M. We got 1 upon M into VR. Same answer. So both are same. The two methods can be used. One is using the P is equal to MW plus C. Second is using directly making maximum mechanical advantage. So I hope you understand all this. Both maximum, what is maximum mechanical advantage, maximum efficiency, law of machine, and all the examples.